Hello everyone. It's good to see you again. Yes, in my mind I see you guys, okay? Yes. So let's just, we are all about stressed out about the situation, but we are going to finish the semester as just best as we can, all right? So let's start lecture 16. This is about probabilities. Well, before the exam, we went over some vocabularies related to probability. So we had a sample space and some outcomes and the events, disjoint event, mutually exclusive, okay? Those things. Now we are going to have some more details, okay? There are three types of probabilities, okay? What kind of probability? So one is that logical probability is obtained by mathematical reasoning. And for example, like rolling a die, okay, or toss a coin, those things you do not have to really explain. You can calculate in your head that, okay, what is the probability that you roll a 4, okay? That is only one side out of 6, so it's just 1 over 6, okay? So those things, for example, like you buy a lottery, okay? So you buy a lottery ticket, and what is the probability that you are going to win the jackpot? Are you going to have a high hope? And maybe not, because there are so many different ways lottery tickets can be made, and only one will be the jackpot ticket, okay, the winning ticket. Therefore, you cannot have a high hope. Yes, we already know that, okay? Those things are logical probability. On the other hand, there is an empirical probability. So you have to experience, okay, that. So probability that a certain brand of light bulb will last more than 1,000 hours. Yes. If you go to Home Depot, there are a lot of different kinds of light bulbs, and they said, oh, this one is 1,000 plus hours or 2,000 plus hours. Well, how do we know that it's going to be really lasting like that? What is the probability of that? Well, we cannot really think this logically. We have to experience it, okay? We have to experience, and really just you install the light bulb in your house, and then, oh, it's going to last more than 1,000 hours. Well, you are going to see it, okay? So that one is coming from your experience. Well, a probability that a person selected at random will be a smoker. Well, smoking trend is going up and down. Yes, nobody knows. Just you have to ask that person, are you a smoker? Okay? Or even now, coronavirus, when is it going to go away? Okay? Well, so that we all go back to normal. What is the probability that it will be done by end of May or end of June? What kind of probability do we know? We do not know. Only after everything is over, the experience will tell. Okay? And the third kind is judgmental probability. J-U-D-G, yeah. Always I'm thinking, is there G if there? No, judgmental probability. This is about your opinion is related. So for example, well, your favorite team is going to win the game. Okay, there is no logic behind it. There is no experience because the game was not played yet. Okay, this is anticipating forward. Okay, so this is judgmental probability. That is like New England Patriots will win next year's Super Bowl. Well, by the way, Tom Brady left Patriots. Well, I don't know whether it's going to be a real factor or not. Still, judgmental probability. What is the probability they are going to win? Well, even bigger. a Democrat will be elected president in 2020, or a Republican, okay, or just more directly, President Trump will be re-elected. What is the probability of that? Well, it is just judgmental, okay? So, well, you will get an A on your next mathematics exam. It's all you know, okay? You judge, and this is, you are the one that who can really estimate. Well, we talk about the properties of the probability. So you remember there's a sample space. Sample space meaning if there are all possible outcomes. So let's say all possible outcomes. So when you look at each outcome, okay, each outcome, you are going to compute the probability that what is the probability. So let's write it this one as like a P1, P2, P3, so on and so forth. Each and every one is, so I'm going to, in general, I'm going to put it like this. Each one is between 0 and 1. Okay? On the other hand, when you add them up, 1 to P2 to P3, so let's say they are all going to Pn, the summation is going to be exactly 1, no more than 1. Okay? It will never happen. Okay? And if it's not, they do not add up to exactly 1, that is not a probability model. Okay? That's what you can say. Alright, based on this, let's solve some problems. Today's problems is not really, not very theoretical, just you apply the concept of this, and then we are going to, I have to draw it thoroughly, otherwise it doesn't look good when I write. Okay, well, example 1, grade distribution. This table shows the probability distributions of letter grades from a mathematics class of 50 students. Okay. And this is the letter grade. So A, and the number of students, that is 11, probability. B, C, D, F. I was about to say E, of course there's no grade E. Well, number of students given like this, okay? So it's from the class, that's outcome, okay? So 21 and 3. So probability meaning over here, go to this class and you just randomly select one student and they ask the students, what is your grade? Well, what is the probability that that person has an A? Well, that means 11 of them received an A out of 50. So the probability, we can say this is 11 over 50. Okay? So in terms of vocabulary, we can call this number of students is frequency. On the other hand, the probability is 11 out of 50, so we can say this one as a relative frequency. So in short, this probability is the same as relative frequency. Okay? And what about B? The randomly selected person received the B, is the probability is 15 out of 50. So of course that is, once you convert it to decimal, 0.22, 0.30, here is 20 over 50, so 0.40, 1, and, I'm sorry, 1 over 50, 1 over 50, so that is 0.02. And here is a 3, the last one is a blank. Well, the probability we can say 3 over 50. Is there another way to think about this probability without writing this one? Okay? The way we think over here is when you add up, okay, let's say we do not know how to do this. So when you add up, the sum has to be exactly 1.00. So you add up all of these and then subtract that one from 1. And then you can get the probability. Okay, so anyhow, this is going to be 0.06. However you do it, okay, you add up, subtract from 1 over 3 over 50, anyhow the probability is 0.06. You may say 6%. Okay, B. What is the probability that a randomly chosen student received a letter grade higher than F but lower than B? Okay, so that person managed that not failing. Okay, so what is that? Higher than F but lower than B. So this from here to here. Just in short, C or D. Correct? Okay, C or D. Well, are they mutually exclusive? Receiving a C, okay, receiving a C grade and receiving a D grade. Of course, one way or another, they cannot occur at the same time. We call that mutually exclusive. Well, and C or D. So whenever you have or, you add. Okay, especially if they are mutually exclusive. And then it is going to be just you add up. You don't have to subtract anything. So this is a 0.4, 0 plus 0.02, therefore 4.42 is the answer. Alright, that was easy. Example 2. I'm telling you, the first few examples are easy. Well, in the middle, couple of them, yes, you have to think. Alright, next one. Today's probability is like mostly assigned. That's why this is the title is assignment of probabilities. We do not really compute, so it's not logical probability. There is no logic behind that when a person receives an A. Okay, only the experience or the data from a class will tell. Example 2. Yes, have you played the scratch-off ticket? For example, like when you go to gas station, yes, sometimes you get a soda and, oh, give me that one ticket. Yeah. Well, this one has a data about you buy a ticket, the possibilities are here. You can win some money, $100, or you can win $10. You can even win $1, or you can win 0. That means nothing will happen. This one, you will lose $10. Well, I cannot imagine how, but anyhow, yes, this is a setting. The probability associated for each winning is 0.02. Again, we cannot think of these things logically, okay? This is going to be just given 0.03 and 0.50. Oops, that is half the cases, okay? So in other words, half the time you play this scratch-off ticket, well, you are going to lose $10. But why do they play? Hoping to win this $100, right? But look at the probability. That is 0.02, only 2% of a chance. But still, some people think they may get lucky. Well, which outcome has the greatest probability? Of course, this. Okay? Which outcome has the least probability? The extreme opposite, that is winning $100. That is the least probability. What is the probability that a person will win some money? So we understand that win some money. So that means it could be $1 or it could be $100. So we understand that this or this or this, they're all mutually exclusive. You cannot have, like with one ticket, you cannot win just $100 and $1 at the same time. So what we have to do, we add 0.02 plus 0.05 plus 0.40. That gives you 0.47. Okay? Or you may say 47%. Well, next one is inclusion-exclusion principle. Do you remember this term? Inclusion-exclusion? So far, our events are mutually exclusive. Okay? So those things are just, they are disjoint. So when you add the probability, just we add these two numbers. However, we can see an event, those two events, that there is an overlap. Okay? So therefore, when you think about inclusion, exclusion, how we are going to say that? Okay. Here is event E and here is event F. And this circle represents the probability that event E occurs. Okay? So, probability that event E union F. E union F is what? All of these. Correct? Okay. That is probability that event E occurs. Yes, E is part of it. I'm going to use another color for F over here. And you add. And then as you look at it, I included this whole circle and this blue whole circle over here. This is what I did. And then I realized that, oh, this portion was added 2 times. Isn't that right? So therefore, you have to subtract 1 time. So that is overlap. Okay? So that is what? E intersection F. We call this one inclusion-exclusion principle. Include and exclude. You saw this one before, right? Where was it? The number of elements in E union F is the number of elements in E plus number of elements in F, and then subtract the number of elements in the intersection of this. So this is applied to the number of outcomes in each event, but this one is for probability. Okay? But anyhow, the way it works, the way we write is the same way. Okay. And in particular, if these events E and F are mutually exclusive means this part is going to be 0. Okay? This part is 0, therefore just you add these two things up. In that case, those Venn diagrams will look like this. Okay. Grade. Another grade problem. As you see, if I use just dry eraser, it leaves a lot of things behind. So I have to use a kind of a damp paper towel. And then after that, I have to dry it. Otherwise, I cannot really write on the board. So, all right. Example 3. Joe feels that the probability of his getting an A in history class is 0.7. The probability of his getting an A in a math class is 0.8. And this is the best scenario, not the best scenario, I'm sorry, that probability of getting an A in history or math is 0.9. What is the probability of his getting an A in both subjects? That is the best scenario, right? Okay, so this one is all the possibilities are in here. So having an A in a history class is 0.7, and receiving an A in math class is 0.8. And the next thing is important. A history or math is 0.9. So that means probability that history or math, so H or M, is 0.9. Okay. Or is what? 0.9. Or is union. So we just learned what? Inclusion exclusion principle, and as you see there is an overlap over here, because first of all 0.7 and 0.8, if you add them up individually you already have 1.5. It's not possible. All the probabilities related to this problem has to be what? Summing up at exactly 1. Okay, so there is some overlap. So let's think about it. When you connect, as before, I'm going to use this. I'm going to look at this one as like a jigsaw puzzles. So 1, 2, 3, and piece number 4 over here. These 3's together 0.9. But when if you add this 0.7 and the 0.8 is 0.8, you are going to subtract this part, right? Subtract this part is 0.9. So what would it be? So 1.5, this number 2 piece is 0.9, so number 2 piece has a probability of 0.6. So now we can separate everything. Number 2 piece has a probability of 0.6, and therefore this is 0.2, and this is 0.1. Okay? So 0.9 is spread out like this. Therefore, what is number 4 piece? This is 0.1. And then we can analyze everything over here. So getting an A in both subjects, so both classes, therefore this part has to be the one is implied over here, right? Both. So that one is going to be 0.6. Okay. What would you call this case? Having a C, having a D, or having an F? We do not know. Simply what? Not an A. Okay? This one means Joe will not get an A in either classes. Yeah, that's what this is. We do not know particular grades, but neither one is going to be